Yeah, there we go. So that's this. Okay. So what are we gonna do today? I probably have a few minutes until like 6:50-ish. We're gonna tackle this. Continue playing around with the ESP32. If you've been following along, you'll see the circuit board and the ESP down here. And I last time got this driver for this light sensor to work on the BH1750. But I also have the BMP180 on board as well. I'm going to add support for that in Cyanobyte. I don't know how long it's going to take. Hopefully not too long. Might take one day, might take a couple days. Either way, I'm going to go ahead and so we have this playground stuff. I have this code base that I took from someone online. It's Mike from Spark Fun. The code base is okay, but it'd be great to have it in a Cyanobyte format so that it could work not just with the ESP32 but any other platform that supports Cyanobyte, like Raspberry Pi or CubeOS or any other similar one. So right now I have this stuff. I put together this light sensor library before. I do want to go print out temp, and I'm just going to move the serial printing. And so that's going to be able to help us a little later, is to verify that we're getting reasonable values. According to this existing driver, the temperature is 24.2. It says Fahrenheit, but that doesn't seem right. It should actually probably be Celsius, right? Because that's 24 would be very cold. Which is around 75 degrees. That seems reasonable, maybe a bit too warm, but that's what we get from the existing driver. So my goal is at the end of this to have 24 come out, or maybe something that's, I don't know how warm it actually is in this room. Maybe it's 75. That would be pretty warm. Anyway, let's get cracking on this. This has some extra stuff. And then this got the pressure stuff in this odd model where you have to start something and then make a delay, and then I don't know. And I guess that makes sense if you're sampling it one time, and then you're going to shut down the device to save power. But if you're reading it continually, getting a small glitch for a second isn't going to be a big deal. You need like a milliseconds, right? Anyways, I do have a BMP280 peripheral file before, but I don't have one on hand, so I do have a BMP180. That's what I'm going to do. BMP. Oh, okay, all the stuff's at the bottom. Address type is 7. I never had a 10-bit address. I've heard they exist, but I don't know why I have an address mask either. It's just there for some reason. So there's a bunch of things to do. Let's just start with the functions. Temperature. Call this title. Temperature as read by sensor. I think there's pressure as well, which I don't even have in my playground example, but we'll see if I can get to that today. So it looks like the way that this works, you write in the control register your command. Oh, I don't understand. Okay, so you write in you have a control register. You read it right in the command that you want it to have. And then you pull it out of a result register, which is 16 bits, thereabouts. And then there's some extra logic you have to do. Yeah. Variables, let's call this one temp, which is a uint 16. There's a bunch of other logic I'll need to do. So let's see logic. First I need to do a send with a value of 0x, nope. send the control temperature to the control register. Now I have to get the temperature back. Change register the result. F6 16 bits. That stores measurement results. Any description. So now I've got to do the first step is, looks like it's just shifting the bits to go from so in that example there it's reading in as a 2-byte array, turn that into a single 16-bit John. Was that supposed to be a bit? I can make that a float. Let me make that a float. No. It's gonna be an N16. It just will be. I don't know why the casting is a double. Anyway, I need to do A equals C5 times TU minus C6. What is A? A is just some temporary dummy variable. We call that raw comp. That is 16. I gotta do C5. What is C5? Well, it's not as helpful. Where C5 is equal to power 2 minus 15. 60 times AC5. AC5 is equal to read your XP2. AC5, okay. I think there's a way I can set it to be unsigned. Signed is false. Title is temperature calibration 5 and signed is false. And description is that. Cal5, which allows us to then do C5, where C5 is a float for some reason. But again, I don't understand why it's a float. I'm just going to cast it as a 16. C5 is going to be the product is that right? Of the division of do something 160 AC5. Power of 2 negative 15. Let's call it temperature. And I gotta get C6. C6 is equal to AC6. P4. Is U int. And if C6 is the same thing as AC6, I guess I don't need to have multiple of them, you know? So that becomes the first line. Now, I have T is equal to A plus MC divided by A plus MD. T is our result. So mathematically, this isn't as terrible as the BMP180, but that assumes that this thing works. We're making some good time, so probably check in this and then check in pressure at another time. Temperature is equal to the sum of raw comp and the dividend of MC and the sum of A, which is raw comp, and MD. And we gotta figure out MD. Oh my goodness. This is just very so for context, I guess we could say MC is equal to tau 211 tau 162 times MC. MC comes from register BC. I don't understand why the name the way they are, so that's frustrating. It's actively making it tougher for me to understand what I'm writing. MD is coming from XB. It'd be great to pass this whole thing off to the engineering team. MC. That's just a sign. And the engineering team is like, oh yeah, I understand all this stuff because I work on it and I can document it correctly. Like, there's no where in this this code what exactly it means to be MC and MD. Raw MC, we have to read in registers temp calibration MC. MC has to be the product of the division of and raw MC power of 211. Is that really what it is? Calculating 160 to the second power? Why would you do that? So I think that is correct. Generate for the ESP32 for peripherals, BMP180. Oop, nope. No, what is it telling me? I messed something up. Temp is not iterable. this one out. No, I didn't want to do that. Just delete that for a second. I understand that I also have to do at some point access control registers, because you shouldn't be able to change the calibration values. Let's take a look at this. Oh, that generated, yeah, because I don't have, this has all the rights as well. I don't want to do that, but I need somehow to put this behavior back in. I want to do it a little slowly. Just delete most of the logic and incrementally, alright. Because the first line that kind of threw the whole thing into a hurdle. And saying send. Line 18. If raw read in temp step key. Huh. Alright. Yeah, that's really, frustrating. Change it to is object. Is mapping raw read. So key is string and flying 49. Why is it only throwing a problem now? Alright. Let's copy in the rest of this logic. Alright, so let's pull up our stuff on the other side. We read in, so we write our thing, we read the result, write the control, read result. We get AC5 from the calibration, AC6 from the calibration. We never calculate C6. That's because it's the same thing. Pow 215 to the 15th divided by 160 times AC5. That's correct. C5 is equal to that rock comps. We do A is equal to C5 times temperature minus C6. We do MC. MC is going to be equal to 2 to the 11th divided by 116 to the 2nd times MC. Just like that. MD is equal to MC MD minus 160, and then we have raw comp. Finally, the original computing variable, whatever, plus MC divided by the same variable again, plus MD. Alright. So let me go ahead and find where these variables or this file is stored so I can pull out the source files just in case the whole thing does not work. Come over here, copy in this, and then we go to the header file. And let's verify. It's because the file is named slightly differently. Safe BMP180. Okay. So now we have to rename that to BMP180 without the SFE. We want to pass in our wire. Should. Okay, so here we go. Now some of this code is outdated. So T is equal to pressure dot temperature as Celsius. And it should just return directly instead of having to pass in a pointer. Alright, so that wasn't that bad. It's reading Lux right now. You have to send the upload command. And I'll update the stuff as we did at the beginning. We're going to say spit out the temperature over the serial instead of the red Lux. Right now on the code it's saying at 24.4 should be Celsius. That's from the original sensor. Let's hopefully get somewhere close to that. Okay, now it's saying negative 49 C. So that is not the temperature. So evidently something is incorrect in the logic, which I really couldn't say what that would be, fortunately. So it's clear that I need to spend a little more time looking at exactly what is happening here. There's a lot of calculations going on. I know some of these are for pressure, and others are not. So when you're saying re-register result to a car, that's pressure. It's unsigned. And temperature, I think I want that to be UINT 16. I gotta do ESP. But should it really be a 16? Because what if it's just not, if it's too cold, right? Yeah, I'm confused a little bit. I will try it out. But it's also possible that maybe it should be a float. Okay, that was a bad idea. Now I'm so far off. Just call it a double. I don't know if that's actually gonna, well, is re-result gonna throw a thing? Oh yeah. Okay, now back to negative 49. I guess that's, I don't know, which one, would it either be really hot or really cold? All the C's, so we're reading in AC, MD, C6, maybe it's because C6 should be a double or something. It should be signed. Let me try. And at some point, I'd probably want to update all of the constants into be real constants. You know, like 2 to the 15th, like 2 to the negative 15th divided by 160. You know, you don't have to. Speaking of that, actually, I was thinking that should be So looking at the original, all of these should be floats. I think it's at least partially responsible for what's happening. Just explain. I could just be a floating thing. Oh, there you go. Yeah, it was just a floating issue. So now it's saying 24 degrees Celsius, which is pretty close, pretty much what I had before. So there you go. Last time it took me a little bit to get through the original light sensor, but now you can see here it took me less than an hour to put together a Cyanobyte specification file for the BMP180 to do temperature sensing, taking the, not just reading temperature, but converting that into a Celsius, which is not necessarily a trivial operation. We can see we have a bunch of register read events and computations, powers, and division, multiplication. But we're getting the values out, and it looks the code looks pretty solid. Honestly, it's not entirely readable, but aside from that, it's pretty robust. So there you go. I think one thing I do want to do is read. What's the field called? And that's read write. Read write. I'm just gonna add some access control. That simplifies the code base a little bit, and it takes all the, so now I can only read registers, I can only write controls, but I can't do anything else. Yeah, like you just write things, like you can't write, but you can do that, so. Pretty good. Pretty happy with how this turned out. Pretty quick as well. Being able to, put all the calculations in this YAML format with the nesting and stuff. It's a little verbose. I will say, but it works, and it works nicely. So, with that, I'm going to end the stream. Next time, I'm going to go ahead and check out this pressure sensor, which is also on the device, and try getting something reasonable out of it. And then there's like these other altitude, sea level. I don't think I need to do those, but maybe you could. Maybe one could do that. Alright, well, happy Friday.